Okay. When they say the max and the min, they mean absolute max and absolute min. They don't mean, oh, let's find a local max and min. Okay? So just to be clear, the max would be, right, if we're saying, and usually on the max, we'll say, find the max on this interval. Okay? So what's the max? Right here, right? Mm-hmm. Okay. And I know we've talked about this before, but the max is 5. Looks like at where? X equals 4. Those are ballparks, but looks like it's really probably above 5, but let's say 5.5. Okay? So don't just tell me what the max is. If you're just going to give me a number for the max, then you're going to give me the y. Okay? If you're going to give me the x value, we could also say the max is 4, 5.5. So be careful about that. The min, where's the min?
It's at 1x equals 1. Negative. Wait, actually, no.
Isn't the min right here?
I guess.
That's the lowest part of the graph, right? Okay, so what's the min at x equals -6? Or what's the min?
-6.
Okay. So there's a lot of different ways you can write the min. If it's multiple choice and they say find the min, this is really what you're looking for right here. Okay, because that's the minimum value of y. And that's what they're asking for, the minimum value of f of x and f of x is y. Okay? Now, on free response, just to be clear, I'm going to talk about the x value, I'm going to talk about my ordered pair, any of those apply, but just be careful when you're looking for the multiple choice. They are referring to the y value. Okay. These are definitions. Let C be a number in the domain of a function. Then f of c is the absolute maximum if f of c is greater than f of O, f of, let the domain be from A to B. How about that? Okay? F of A and f of B. That's not really good notation, but can't. Let's see. Let's do that. For all x in the domain. Okay? Absolute minimum, f of c is less than f of x for all x's in the domain. Okay? All right. F of c is less than f of x for all x's near c.
Miss,
I like that. Yes, ma'am.
Miss Butler, you say near C, like, how do you quantify that?
Because that's a good question. You're going to, if this is C, I'm the highest point over on both sides of C. So, I mean, this isn't near. This is, you know, on both sides of C, near it. Like now, I'm not going to call this a local because I don't know what's near it on the other side. So it is kind of a perspective thing, but the local minimum, oopsie, I did that wrong. Anybody catch that? It's greater than, because that's the max. minimum is less for all x's near C again. Okay? All right, okay. I don't know that you need to write this, but the near to me helps me with the local. Absolute, I think you have a good visual of it. Doesn't. Okay. It also sometimes referred to absolute as global maximum. Okay, so which one's the absolute global or the global max? It's at E. Okay, so there's the absolute, and I think where's the absolute minimum on A through B? Is that what we're talking about on AB? Kind of assumed here at A. Okay, and local. Is there a local max? Let's see. Yep, that's the highest point here, but it's not higher than that, so it's not. Okay, is there another one? Nope. How about local minimum? D and B. Okay. Now, when you're listing all the local extrema, you will also list the absolutes because they're local as well. Okay. So your local max, for example, on here will be at x equals, see? X equals E. Okay, your local mins will be at x equals A and D and B. Okay, this is another thing to remember. Local extrema. Remember, this is the plural for max and or min. Okay, cannot be at the endpoints unless it's an absolute max or min. Okay. So the only reason we called A in the locals and B, yet notice, wait, yeah, B shouldn't have been a local. This should not be a local. Because we don't know what's happening afterwards. We don't know if it's keeping, it's just going down. We don't know if it's going back up. We don't know. Well, A, it's because it's an absolute. That's why we listed it. That's why I wanted to make that point. So I'm glad I.
So would that also be a minimum?
Yes. Yes. Yeah, you list it there too. Okay? So be careful about that because you don't know what's happening near it. You know what's happening before it, but you don't know what's happening after it. So that's why that doesn't work. If it's an absolute, the lowest point, then you know, okay, I'll take it. And usually that's not going to be an issue, but occasionally it is. There's some goofy problems in the book with those. All right, you good? Okay. Extreme value theorem. We've had the mean value theorem. We've had the intermediate value theorem. Now we have the extreme value theorem. Okay? The f is continuous on a closed interval, A to B. Same condition as the other two. Okay? Then f has both a maximum and a minimum. Okay? That's your extreme value theorem. Has to have one. Okay? to be clear, the conditions of extreme value theorem. This is the given piece. You have f of x has to be continuous and has to be on a closed interval. Okay, two conditions. Closed interval. So it has to be end points. Okay. Now, what you need to understand is just because if it meets those conditions, it's absolutely going to have a max and a min. If it doesn't meet those conditions, it could have a max, it could not, could have a min, it could not. You'll just have to see. But it's guaranteed if we meet these two conditions. Okay, so let's look at these three examples. And it says, using the graphs, find the minimum and the maximum values. Notice there's not the word absolute, but it's assumed there, the minimum, not the local, the absolute minimum values on the given interval. Here's the given intervals, here, here, and here. If there's no maximum or minimum value, explain why, because something failed in something wasn't happening there, okay? So, first one, it's a closed interval. Is it continuous? Yeah. Yes, so the conditions are met. Closed interval, continuous. All right, that means it should have a max and a min. Not should, does. All right, what is the max, Sarah?
It's at 2.
Okay, what is the max?
2.5.
Okay. Max is 5. And that's okay. I wasn't telling her she was wrong. You were good. All right, and what's the min, Lydia? 1. And where is it?
Here.
Okay. X equals 0. Good job. So you can say it that way, okay? And you didn't say it wrong. You gave me the max, which is at x equals 2. What is the max? 5. Okay? Very good. All right. Is this a closed interval? Really? Look. Is that a closed interval? No. Okay. Not closed interval. This is an open interval. Got the open circles on both ends. Is it continuous?
Yeah.
Yes, so we have met 1. That means we may have a max, we may have a min. We don't know. There's not guaranteed because we haven't met the conditions. All right. What's the max? Is there a max, Elena?
Yes.
What is it?
It would be as close as you could get to 5.
So, get close. I can get closer. Can you get closer than 4.999? Is there a max, Elena? No max. Okay? Because we can't identify how close we can get there. Somebody can always get closer, even though we said, okay, I know I'm pretty close to 5, but I'm not at 5, so how close am I? Well, I don't know. I don't know. I just know I can't get there. All right. Is there a minimum? Yes. What is it? Okay. So you may or may not have them if you haven't met the conditions. If you've met the conditions, you have to have them. All right. Do we have a closed interval here? Is it continuous? No. So this we may or may not have a max or min. You just have to look. It's not guaranteed unless we meet the criteria. All right. Connie, do we have a max?
Yeah.
What is it? Very good. Okay. Do we have a min? Kara? No. No min because, again, it would be there, but we don't know, No. Okay. Well, this is my extreme picture.
Yeah.
It's really extreme. No, it's not gonna be a me. I'm not extreme. This is extreme amount of piercings, right?
Oh, those are yours.
Those are piercings.
Are there tattoos in there too?
Do what?
Are there tattoos in there?
Yeah, there looks like there's a tattoo up there. Do you think that's a little extreme? Well, he did it to himself. He pierced himself.
But probably was a deep emotional
He probably has deep facial pain. All right. Okay, so this is the part that should be familiar. EDT, not so much. The derivative of the function can tell us whether the function assumes any maximum or minimum and where these values are located. Okay? The derivative. And probably know this. Where do we find where the maximum or minimums are? Remember?
It's where the zero is.
The slope is 0. So the derivative is 0. There's a max or min. Okay? And how do you know if it's a max or min? You have a slope of 0.
It goes from positive to negative.
What do you mean it?
If you like interval testing, then
So where are you interval testing? F of x? The derivative? All right, very good. Okay, so that's all coming. All right, critical points. Have you called them critical points before? The critical points, let f of x be defined at x equals c. Okay? F prime of c equals 0, or f prime of c is undefined, then x equals c is a critical value. Okay? And the c, f of c is a critical point. So let's say, for example, f prime of x is 4 minus x over x plus 2. Okay? What are my critical points? Where does this function equal 0? Okay. And f prime of c is undefined at x equals -2. Okay, so those are my critical values. Okay? What's going to happen at these critical values, you suppose? That's where you're going to find your max and your min. The critical values or at the end points. Okay? Critical values are where you're going to find your stream values, or they may hit your endpoints if you have a closed interval. Okay? All right. Okay, read this and we'll paraphrase. Just because the derivative is equal to 0 or undefined does not mean there's a relative max or minimum there. Relative extreme can occur only at critical points, and critical points occur only when the derivative is 0 undefined, but it is possible for the derivative to equal 0 or to be undefined and there be no extreme values there. Let me give you an example. Let's say f prime of x equals x minus 2 over x plus 3 squared. All right, what are my critical values? Okay, I should interval test, okay, at -3 and those critical values. So I'm going to check f prime, okay. Where is f prime, what is f prime doing over here? So positive or negative? Okay, over here? Like 0. Over here? Okay. So what's going on here? Is there anything going on at -3? Okay, so is there a max or minimum there? No, but the critical value is still -3, but that's what this is saying. Just because critical value doesn't mean there's necessarily a max or minimum. Is there a max or minimum at x equals 2?
Yeah.
What is it? Minimum, because we're going from f prime is changing from negative to positive. That's minimum. Yes.
Is it kind of like the squares and rectangles thing where it's like all max or mins are at a critical point, but not all critical points have a max or min?
Yes, that's exactly what it is. So when you get, sometimes, good question, this is more specific. So let's say we have f prime equals 4x, make it real elaborate here. Okay? So we know we have critical values at 0, 1, -2, -6, and 7. Right? And now all of those are going to give us max and mins. It depends on how it changes. Because with that one square, it's not going to be every other. Okay? That's my point. Not all are max or mins. Okay. Any questions? All right. Okay. Find the absolute maximum value of continuous function f on a closed interval AB. Remember, if it's continuous, if f is continuous on a closed interval, you're going to have an absolute max and an absolute min. Find the values of f at the critical numbers. Find the values of f at the endpoints. Biggest one is the max. Smallest one is the min. Okay. Absolutes. If f is continuous and on a closed interval, it has to have a max. This is how we find it. Okay, so extreme values, those are absolutes, max, and min, and local. Okay? All right. We're going to solve analytically first, and then we'll confirm graphically. All right. F prime of x is what?
X minus 2 to the negative 1.
Okay. All right. So this is F prime. You need to know critical values. F prime of x equals 0, or F prime of x equals does not exist. All right. What are my critical values? Is there where 2/3 x to the negative 1/3 equals 0?
Yes.
That really is this. You really want x to be 0?
No, then, well, it's still a critical value.
Yes, that would be over here. Yes, okay. Is there any place where this equals 0? 2 almost, no. Okay, so in this case, we have one critical value is x equals 0. Okay? All right, so we're finding the absolute max. We found the critical values, all right? So that was x equals 0. Part B says find the values of f at the endpoint. So f of, what are the endpoints? And f of 3 and f of critical values. Okay? So number 1, find the values of f at the critical numbers. That would be this. And 2 would be right there. Okay? All right. What is negative 2 to the 2/3? Negative 2 to the 2/3. cube root of 4. 2 here. Is it positive? Is it negative? -2 squared is positive, right? So cube root of 4. All right. I wrote that really badly. All right. What about f of 3? 3 to the 2/3. What's that? Cube root of 9. So far, which one's bigger? Cube root of 4 or cube root of 9? Cube root of 9. Okay? 0 to the 2/3. 0, right? Okay. So, absolute max is the biggest one of all those. At x equals 3, right? Or the absolute max is at 3 cube root of 9. Okay? What's the absolute min? 0. Okay? At x equals 0. So, just be careful when I say that. Okay, extreme values. We won't do the locals. The locals require something else. Can we tell that this is going to be a local? Max or min? This one? Do we know if it's a local right now? We don't. We would have to do what to find if it's a local? Interval test, right. Or graph. Do the graph. And see. Now, if we had the graph from the beginning, let's look and see what we could do. All right, x to the 2/3. All right, so graph, what my window looks like. Let's just do standard window. This is my graph. It's one of those custom things. Okay. Now that's f of x. You see why the derivative does not exist at 0 because of the cusp? Okay, but it still can be a max, even though the derivative does not exist. Or in this case, a min, sorry. Okay, if we are cutting off from -2, which is right here, 2, 1, 2, 3, right here is taller than that place. So that's why that's the max. And that's the min. And when I say the, I mean the absolute. Do you see why we don't have another local? Okay, we would either have to do the graph or interval test down locals. Okay. All right, let's do this. Even if you have a calculator, your graph is not ever a reason to say, because that's where it looks like a max. Now, if it's a multiple choice, you're free to do that. But if it's a free response, you need to give me calculus analyzing methods there. All right, G prime. What is that, Elena?
Negative b to the negative x.
Yep. What's the rest of it?
Minus 10x.
Okay. What is this telling us? That's interval. So we're only looking at the function between that and that. Now, I have no idea what that function looks like. Okay, if we can verify it when we're done, but all right, we need to know where g prime of x equals 0 or where g prime of x is not existing. Okay, negative e to the negative x equals negative, oops, I'm a little ahead of myself, minus 10x equals 0. Okay. How are we going to solve that? You throw the 10 over? Okay. 10x rather. All right, now what? That work? Divided by negative. Now I have perfect. Okay. So ln negative 10. Yeah. Equals negative x.
Yeah.
I don't think this is really solvable unless we have a calculator. So let's get that actually solved with our calculator. You'll have the calculator, but you just don't kind of graph of the original function for it to be a reason. Okay? All right, so we want to graph, or we want to solve. Looks like I've got two answers here. But remember, I'm only looking between negative 4 and 2. But I got 2 zeros, so. Did y'all get them? They're both between. You could do an intersection or 0, whatever you like. All right, I got 2. Did you all get the same ones? Y'all are talking to me? I got negative 3.75771152. Okay. And I also got 0.1118326. Did you all get that one too? Yes? No? Maybe? Get it coming? Yes.
I have negative.
Is it negative? Yes. Thank you. Okay. Is there any place, I did zeros, anybody do intersections? Okay, so work the same. All right, is there any place where the G prime does not exist? Think about the domain of this G prime. Is there any place where we would be like, within this function, is there any place that would be a problem? Okay, so this is good. All right, so these are our critical values. All right, now, we are going to check f of negative 3.5771522, whatever that is, negative 0.1118326, and don't forget your endpoints. Okay? Now, there, and want to see all those. So write them all down as you find them. Don't just say, oh, I'm not going to count that one because it's smaller than the one I already have or whatever. Write them all down. Okay, so if you had your function in there already, which you may or may not have, I didn't put it in there. You could do a value instead of doing that 4 different times. So your original function was e to the negative x minus 5x squared. So I'm putting that in y2. I'm going to turn off this one. I might need it some more, but I'm going to turn it off. So I only get one value showing up. All right, so I'm going to put in negative 3.577152. Or not. 57, missed my 3. Dang it. Value. Negative 28. Point. Just do that so I have some verification of that. Then I put in negative 0.111366, 1.055, negative 4, negative 25-ish, and 2, negative 19. Okay. So some kind of documentation that you found them all. And now you pick out, did you all get the same numbers? All right, so where are the max at, where's the max? Lydia, where's the max?
The max is at the largest value, so it's at 19.
I think that's negative, isn't it?
Oh, I didn't see the negative. Excuse me. So it's at 1.055.
Okay. The max is, did you not do these?
It is 1.005. It's at negative 0.111836.
We can round a 2, 3 at the end of all this, okay? And then the min is what, Sarah?
It's negative 28.29, or wait, first equals negative 3.
Okay. You can round these at the end of your problem, but just be careful about rounding when you choose to. 3 digits at the end. 5 is usually safe. If you do it before that, 5 should be safe. But, okay, so that's your answer. We do need our calculator. We are not justifying the width or breadth of the statement. Okay. Analytic methods. All right. Any questions? Anybody? You're all good? All right. Okay, this is an AP problem. Okay, it's a little bit different. What is it called? Approach. Okay, first of all, this is G prime. Okay. Let G be a function where the derivative of G prime is continuous and has the graph shown above. Which of the following values of G is largest? Okay. So we're looking for a max. Anytime you have this, that's max. So you have to look. G of 1 is max. So basically, this is like what we did at the end of that problem. G of 1, G of 2. G is the function that we don't know about. G of 3, so on and so forth. Which one is the maximum? 5 or 2? Why are you even saying 5 or 2? So those are the critical values, okay? The critical values are x equals 2 and x equals 5, okay? That's where they can be. We don't really have a closed interval, but although we're only looking from 1 to 5.
We also have like, does he have that four there?
No, this is G prime.
Oh, okay.
But yeah, if that was G, definitely had a critical value because there you'd have a G prime that doesn't exist. Good job. Okay? So which one is it, 2 or 5? 2 with a question mark? Convince me, Kara.
Increasing and then decreasing.
So G prime is positive here and negative here. On the other hand, it's negative here and positive here, right? So you're going from G prime is positive to negative, that's a max. This is a min. So it's got to be here. Okay? No care. All right. The maximum is my point in giving you this.